Hello guys, my name is Venkat Sai. I am currently pursuing Sri Venkateshwar College of the Engineering. Today we are discussing about Introduction to Non-Deterministic Finite Automata. NFA are computational models used in the field of computer science to describe the behavior of certain systems. They are characterized by having the ability to be in multiple states at the same time, providing flexibility in representing computational processes. Moving towards next topic, definition and characteristics of non-deterministic finite automata. Flexibility, complexity, efficiency. Flexibility means NFA allows for multiple possible transactions from a single state when presented with the same input, providing a non-deterministic way to process information. Complexity, they can represent more complex systems and process compared to deterministic finite automata due to their non-deterministic nature. Efficiency means NFA often offers more efficient solutions for certain computational problems due to their flexibility in state transaction. Moving towards next slide. Comparison with deterministic finite automata. Transaction function. DFA having a single unique transaction for each input symbols, which NFA can have multiple potential transactions. State representation. DFA have a clear and unambiguous state transaction diagram where NFA can have multiple paths and states in response to the same input. Acceptance criteria. DFA accepts or rejects a string in the state, with NFA can accept a string if there are least one possible path that leads to acceptance. Transaction function and state diagram representation. Transaction function of NFA provides the rules for moving from one state to another in response to input symbols. State diagram NFA are visually represented by state diagrams showing the states and transaction between them, illustrating the non-deterministic behavior. Acceptance criteria for non-deterministic finite automata. Non-deterministic acceptance. NFA accepts a string if there exists at least one path that lists an accept state, providing flexibility in this acceptance criteria. Multiple transactions. They can utilize multiple transactions to process and accept input strings, offering a non-deterministic approach to decision making. Conversion from non-deterministic to deterministic finite automata. Number one, deterministic equivalence. The conversion process aims to establish a deterministic equivalent for a given NFA, ensuring unambiguous and predictable behavior. Subset construction. This technique involves the criteria of states and transaction based on the power set of states in the original NFA, resulting in a deterministic structure. Limitations and challenges of non-deterministic finite automata. Complexity. NFA with a high degree of non-deterministic can lead to complex behavior patterns, making analysis and prediction challenging. State explosion. In criteria case, the number of possible states in the NFA can exponentially grow, leading to state, explo- state explosion and computational inefficiency. Algorithm implementation. Developing algorithms to handle non-domestic behavior can be more intricate compared to domestic system, posing implementation challenges. Applications of non-deterministic finite automata in computer science. Linux analysis used in pattern matching and tokenization process for text processing and compiler design. Network protocol utilizes in representation and understanding the behavior of complex network protocols and systems. AI and NLP applying natural language process tasks and developing of AI systems for language recognition. Application of NFA in pattern matching and Linux analysis. Pattern matching. NFA are used to implement pattern matching algorithms in string matching. Applications aiding in tasks such as data validation and information retrieval. Linux analysis. In complication theory, NFA are employed in Linux analysis to recognize tokens in the source code of programming languages. Data validation. The non-deterministic nature of NFA allows for efficient validation of complex patterns in various applications. Examples and case studies of non-deterministic finite automata. Programming languages. Many programming languages utilizes NFA for lexical analysis and parsing. forming the basis for syntax and structure recognition. Regular expressions. Regular expressions central to text processing and pattern matching are often implemented using NFS for efficient pattern recognition. Conclusion and key takeaways. Flexibility in modeling. NFS provides a valuable tool for modeling real-world systems that involves non-deterministic and concurrent behavior. Challenges in analysis. The complexity of non-deterministic behavior required advanced analysis techniques and algorithms approaches. Practical applications. Despite challenges, NFS continues to find diverse and impactful applications in computer science and detailed fields. Thank you.